Hi everyone, João here, and today is another day to get crafty with science. I want to show you a fun way to learn the three main types of hydrolysis, something that might be useful for anyone learning organic chemistry. And before we dive in, let me quickly give you a bit of context about hydrolysis. In acid-base chemistry, hydrolysis is the reaction of water with an ion to produce either a hydrogen ion, or H3O+, or hydroxide ion, or OH-. In hydrolysis, there is always a reaction of a charged ion with water, and not a neutral species, like a neutral molecule. In salt hydrolysis, one or both of the ions in a particular salt is hydrolyzed. Now, there are three common types of hydrolysis depending on the types of molecules involved: salts, acid, and base. Learning a topic like this can be a bit boring, so my goal in this video and in this channel in general is to find fun ways to take a medical science topic and learn it while you play around with craft and stationery materials, which I love. Doing something creative with my hands always helped me learn any topic, so I hope I can share some useful tips with you. The first thing I did was to grab some colorful craft paper. For this specific project, we will need 5 distinct colors. The next thing I did was to cut out as many small circles I could from each sheet of paper. I cheated a bit and used my Cricut machine to help me speed up the process. You can, however, also do this process by hand. I also had a little helper here, little Massey, always curious to see what I'm up to. Like I said, make sure you fill each sheet with as many circles as you can. Each circle will represent a different atom. We will need oxygen, carbon, sodium, nitrogen, and hydrogen. So try to create different sizes for each atom. I ended up with the sheets cut like this, and with lots of cutout circles like these. We won't need these many, but I will save some for later for other projects I might be doing in the future. After cutting all circles, I grabbed an A3 white piece of paper. I wanted to use this A3 sheet to fit all 3 types of reactions, but since the circles were too large, I had to find a solution for that. So I cut the A3 sheet in half, and in a half A3 sheet, I was able to place an entire reaction. I ended up using 2 A3 sheets since I needed 3 halves for each reaction. Again, I placed all the atoms down for the first reaction, that way I knew more or less where I can glue them down. Then it was time to grab my glue stick and get to gluing these circles down. This is always a relaxing moment. Gluing while I listen to my favorite podcast. Which, by the way, what is your favorite podcast? Let me know. I might be listening in the future. As you can see, I started using tweezers, but later found out that using my hands was much easier. So I repeated the process for the 3 reactions, glued all the atoms to the halves of the A3 sheets, and as you can clearly see now, the atoms have different sizes because, like I mentioned before, each color represents a different type of atom. Now that all the atoms are glued down, it is time for us to add the text for each reaction. I wanted to get a sense of where things go, so I used my mechanical pencil to sketch out those elements. First, for salt hydrolysis. I'm adding now the bonds between the atoms, and then the letters for each atom, starting with the orange atoms, which I used for carbon, the pink small atoms for hydrogen, blue for our oxygen atoms, and green for sodium. On the last diagram, you will see me using yellow for nitrogen. All atoms for sodium acetate are complete, so I moved to water. Since this first reaction is happening between sodium acetate and water, I will add a plus sign between these 2 molecules. And let me tell you, plus signs for some reason were just not happening for me. Who knew it was so hard to draw pretty plus signs? Or maybe it's just me. Once the plus sign was finally in, I drew the famous reaction arrow, which shows the direction in which the reaction is happening, or the products in that reaction. In this reaction, we will end up with 3 products separated by 2, again, plus signs of hell. Titles, atoms, plus signs, and arrows are all in. Time to add the names of the molecules. First 2, like I mentioned before, sodium acetate reacting with a molecule of water. As for the products, we will end up with acetic acid, sodium, and hydroxide. Now that I know where everything goes, I will be using my Stabilo black marker to fill the title, arrows, and plus signs. Then I will go in with the fine tip black Stabilo pen for the rest of the letters in both the names and the molecules. I use the same pen to write the letters for the atoms and to highlight bonds between them. And that was it for the first type of hydrolysis reactions, salts. It was time to move on to the second type of hydrolysis, acids. This time we have a molecule of acetic acid reacting with a molecule of water, which will give us 2 products, acetate and hydronium. You can see that in all these reactions, the 2 hydrogens and 1 oxygen become part of the new products. So no atom is lost in these reactions. Same amount of atoms in reactants and products. And we are now moving on to the third and last type of hydrolysis, bases. We repeated the process of adding all the text and symbols to the diagram. And as you can see on the reactant side, we start with a base, ammonia, and surprise, surprise, a water molecule. And ended up with an ammonium molecule and a hydroxide molecule. You can see here that ammonia stole 1 hydrogen or proton from the water molecule. Once all the information was added to these images, I quickly cleaned them up using an eraser. Remember, I used pencil in the beginning and you can still see some of the pencil tracings, so erasing makes it all shiny and clean. So we are done with the 3 diagrams for the 3 common types of hydrolysis. Starting with salts hydrolysis, which occurs when a salt from a weak base or acid dissolves in liquid, like our friend here, sodium acetate. When this occurs, water spontaneously ionizes into hydroxide anions and hydronium cations. This is the most common type of hydrolysis. Then we moved to acid hydrolysis. Acid hydrolysis is the reaction of an ion with water to produce a hydronium ion. And as you can see here in our example, acetic acid lost an hydrogen to water, and we were left with acetate and hydronium. Lastly, we have our base hydrolysis diagram. Base hydrolysis is the reaction of an ion with water to produce a hydroxide ion. 1 hydrogen or proton says bye-bye to the water molecule and joins ammonia, which becomes ammonium. As you can see here, we are then left with a hydroxide ion. And that is it for this video. Let me know in the comments what other topics would you like me to cover. I have a lot of fun giving a crafty twist to any medical science topic. Spending time creating these allowed me to learn and retain the material. At least for me, it was much easier than reading a textbook or my notes. Hopefully it will also be helpful to you. Like this video so I know you want to see more of these. And subscribe to the channel, hit the notifications bell so you don't miss any future videos. I will see you in the next video.